Hi, good morning. Today I'm going to go over our project that is going to be an in-class assignment for Friday. Today is going to be an overview when you get a practice. Tomorrow you will be doing a rough draft and peer editing, and then it will be an in-class assignment on Friday. So it is a test grade. On Friday, you can bring things, but you're going to get a clean copy and you're going to rewrite it onto this paper. And then next week we'll start our trading unit. Okay, here's the overview of the project. You are to, it's called Braking Distances Project. You are to create a real life driving scenario that includes a road condition, a reaction situation, and has two outcomes, a successful one and an unsuccessful one. Decide a reasonable range of speeds. Now I've provided you with speeds, but you can change them if you want to. Show your work and graph the scenario with distance values being the total stopping distance. Make sure to label everything clearly. Limit your story to the box below, so be creative, have details, and be succinct. So I'm going to start off by showing you some sample projects so that you can see what other students have done. So this student earned an A. Now it's a little hard to see, sorry, on the Zoom here. It's a dry and windy day. Since it's a dry and windy day, that means the road condition is going to be dry. You are traveling in your car, and since the roads are empty, you're traveling at 50 miles per hour on the street when a stray cat from a nearby neighborhood begins to walk across the road in front of you. Outcome 1, 50 feet. So they labeled it separately. Outcome 2, 175 feet. Since you are practicing for your driver's test next week and are hyper aware, your reaction time is 0.3. Now, reaction time on average is 0.75 seconds. But they explained it, this person explained it by saying that since they are practicing for their driver's test. What is your total stopping distance? So, outcome 1. Now, what they did was they first calculated here at 30 miles per hour, and I will show you how to calculate your reaction distance again. 30 miles per hour. Their reaction distance they calculated was 21.9. Their braking distance was 1.11. So their total stopping distance at 50 miles per hour was 133 feet. So the first outcome is the cat jumps out of the way just in time and thankfully doesn't get hit. Doesn't get hit. They were at 50 feet, which is less, but they said they jumped out of the way. Outcome 2, you were thankfully able to stop the car. So technically on outcome 1, they would have gotten hit since at 50 feet away, but the student didn't want the cat to get killed. So they said that they jumped out of the way, but technically they would have gotten hit because look how they showed this. 50 feet is less than 100 and 133 feet. That's how I know that the cat would have been hit, because when they calculated it, what they said at 50 feet is less than that. Outcome 2, you were thankfully able to stop the car 41.89 feet before the cat, and it's able to safely cross the other side of the road. Now, this one, the cat was at 175 feet. That's what they calculated. And it's less than 100, it's greater than 133 feet. So they just subtracted those two numbers, and that's how they knew that the cat survived on the second one. Now, this was a 100% project. They got 100% on it. So not only was their story great and their outcomes were right, they put a less than and greater than sign to indicate if they would not have survived or they did survive, successful or unsuccessful, but they also graphed it well. So when they graphed it, scenario here, this is the cat here at going 50 miles per hour, the cat's here and would have been hit because this is where you would have stopped. Scenario 2, the cat's here at 175 feet, but you stopped before you braked in time before the cat. So this is showing me on your graph, and they wrote their own graph. I didn't write it for them. They labeled their own graph and they did their times. Now, reaction distance is going to change depending on your speed, which is what we've been working on. Braking distance, we've done a ton of those already. using the formula, this formula right here, according to your road condition. You have to add the reaction distance to your braking distance. That's your total stopping distance. So this column right here, as labeled here, is the X values. This is what, for the X values, this is what's down here for the total stopping distance. The Y values here are the speeds. Okay, this is a 100% project. Now I'm going to show you some other ones. Let's see this one. Okay. You are driving on dry asphalt going 30 miles per hour and are headed to Cleveland High School. As you make a left on Roscoe, a huge plastic bag flies 200 feet in front of you. The morning fog clouds your vision, so it takes you 1 second to react before you slam on the brakes. Would you stop in time? You continue driving a little shaken up, and once you think you're in the clear, the relentless winds throw a tree branch in your path 50 feet away. At this point, you are traveling 35 miles per hour. She changed her miles per hour. I would not suggest doing that. I would keep it the same miles per hour, so you don't have to recalculate it. Are you able to stop in time? Now, this is not 100% because on their graph, everything was correct what they did, but on their graph, they did not indicate the 200 feet where they were. So let's see, going 30 miles per hour, he is going 30 miles per hour, right? Distance, 200 feet, right? Which would have been over here. So she would not have hit the plastic bag. Now 50 feet away, going 35, 50 feet away is right here. And you wouldn't even have stopped here. So definitely the tree branch, you hit the tree branch. So that was the two things that they missed. They had to say, they didn't answer their question on whether or not they hit it or they didn't hit it. Okay, let me show you another one. So these are all A papers. They're not all 100%, but they're all A papers. It's been a long day at school, sports, and work. My friend is driving me home. We are both tired. He is driving at 40 miles per hour and it recently rained. So the asphalt is wet. So that's the driving condition. The road is empty and quiet when all of a sudden a stray cat jumps out into the road about 200 feet away. It takes him 1.2 seconds to react. He will not be able to brake in time since he will come to a full stop at 248.18 feet. It took 70.4 feet to pass before the something, can't read that, plus 177 feet to brake. For the brake. Luckily, he swerved out of the way and missed it. The cat's friend at 100 feet away would live since the car will stop around 248 feet. Both cats lived. Okay, so here's their graph. Meow number 1, meow number 2. This one would have been hit if it didn't jump out of the way, and this one wouldn't have been hit. Okay, because they stopped. So in other words, when you graph it, anything that's on this side, anything that's on this side of the graph survives. Anything that's like on this side of the graph does not survive. Okay, so this, your scenario here, so you got to look at your feet. If you notice, a lot of the kids here actually erased, there's erase remarks here. Because after they did it, they realized, okay, those numbers, I have to change those numbers. Okay, so let's go to reaction distance now. So if you have this paper, let's flip it over to the back and we're going to calculate, how do you calculate the reaction distance? So I'm going to think of a scenario. Mrs. Stewart is driving to school and accidentally, so Mrs. Stewart is driving to work and accidentally spilled her coffee. When I look up, I see that there's a ball that rolled into the street. It took me 1.3 seconds to react before I press the brake. Oh, I am also traveling at 25 miles per hour because that's the speed limit at school. How far do I travel before I actually hit the brake? So those are my key points. So you take your miles per hour, which is 25, and you multiply it by 5,280. So 25 times 5,280. That becomes 132,000 feet. You take that feet number and you divide it by 3,600 because that's seconds per hour. So now I have traveled 36.6 repeating feet, and it took me 1.3 seconds to react. So I take that number now and I multiply it by 1.3. That means before my foot even hit the brake, I traveled 47.7 feet. And what we did yesterday was that we worked on different scenarios and I had you guys calculate that. Now, 47.7 feet. Now let's say I take that one and I put it into my story. So at 25 miles per hour, so that's my story, the other side's my story. At 25 miles per hour, my reaction distance was 47.7. Now, because I have to graph this, I have to do my reaction distance for each of these speed limits. So I have to do it for 5 miles per hour, 15. This is my story, but I have to graph this. So I have to do my reaction distance 1, 2, 3, 4, 5, 6 more times. Just the reaction distance. And it's super easy because watch what you do. You take your speed, which is 5. You don't even have to show your work if you do it on the calculator. 5. I multiply it and you could just follow your steps by 5,280. I take that number, I divide it by 3,600. And my reaction distance has not, my reaction time has not changed. Don't change your reaction time. It's still 1.3. I take that, I multiply it. Oh, that does not seem right. I multiplied instead of divided. So let's try that again. Clear. 5 times 5,280. Take that number, divide it by 3,600. Then I multiply that by 1.3. Okay, my reaction distance is 9.5 feet. I do it again for 15. 15 times 5,280. Divide that by 3,600. Multiply it by 1.3. And now it's 28.6. You keep doing that for all of these. So I'm not going to continue it now because I'm recording. I don't want this to be too long. But now let's calculate your braking distance. So my braking distance, I'm using this formula right here. I'm going 5 miles per hour and it's a dry day. I didn't say that in my story. It's a dry day. So my coefficient of friction is going to be 0.75. Okay, so I'll just show my work up here because I have some space. My speed is 5. 5 equals the square root of 30 times 0.75 times my distance. So this is my work only for 5 miles per hour. How do I get rid of that sign? Square both sides. So now it's 25 equals 30 times 0.75 times d. I want to get d by itself. So divide both sides by this, 30 times 0.75, 30 times 0.75. And it's lucky you have these fancy calculators. Let's go to the fraction. Alpha F1 fraction. 25 divided by 30 times 0.75. And it's 1.11. So 1.1. I'm only going 5 miles per hour. That makes sense. So look at my total stopping distance. This is what you're going to graph right here, which is X, your total stopping distance. You see, there's a plus sign here. So you're going to add this one plus this one, and that's your total stopping distance. This X value, it's Y. So 1.1 plus 9.5, that's now 10.6. This is what I'm graphing. Okay, I already put the 5 miles per hour here. Okay, this is the part that I'm graphing. Now I'm going to do the exact same thing here, but instead of 5, I'm going to put 15. And then instead of 25, once I have all these values here, I'm going to graph them here. And the only part that I didn't do for you was to figure out what my distance is here. So you got to see what my numbers are going to come out, because everyone's numbers are going to be different. So it's going to take me quite a bit of time for me to grade these, because everyone's is going to be different. And you're going to graph it. Once you do it, you're going to graph it. And I did not do an outcome of scenario with my reaction. I'm driving to work. I spill my coffee. You know, I look up what I say. Oh, I did say that there was a ball there. So I have to see if I actually hit it or not. And then I could either have a kid walking across the street or something. I can do another scenario. So overall, that's how you do this. There's quite a bit of math involved. That's why we have 3 days to work on this in class. So you can work on the reaction distance today, right? I can check 1 or 2 of them once you get them all done. You can work also on the braking distance here. You add these together. And really the hard part after doing this part's pretty easy, the math, because it's the same math. The hard part is just figuring out, okay, what increments am I gonna put this in? Am I putting them in 10 or 20, right? And then thinking of your story. So Friday, when you come to class on Friday, you're going to get a blank one of these, probably gonna be in a different color. And you're also going to get this page right here. So this page is where you're going to show your work. Here's the coefficient of friction. This is where, see how he showed all his work? Same thing with his reaction distance. Bonus section, you can draw a picture, right? So he drew a picture here of his first meow and his second meow. So 3 days worth of work. Today you'll get started, maybe thinking of your story. And again, you could just bring it all. You're just going to have to transfer it to another piece of paper so I know that you're doing it here in class, okay? That's it. Let me know if you have any questions, and I'll be happy to answer them.